Depends on how the time is. That's the plan for today. So to recap what we talked about redundancy with active-active, we had two firewalls, two physical firewalls. If I wanted both to be used, I could not use it with a single context. I had to create a multi-context environment where I would have two contexts, let's say context 1, which would be replicated on both the physical firewalls, and context 2. I had a common outside network where I would connect all the devices to my outside network. Internally, I had two segments. I had the segment for context 1, maybe let's say the sales department. And all my salespeople were here. And I had my, let's say, marketing department over here, connected with all the marketing users over here. The advantage of doing that was that I had the ability, although I could not have a context active on both the boxes at the same time, but at the same time, at least I could have context 1 be active on the first box and context 2 active on the second box. So all the traffic for the sales department, because this is the active context when everything is up and running, is going through this one, and the marketing context would use the second box to go out. So at least both the boxes were being utilized. This is what was active-active, and this was the only thing that you could do up until 9.x. Although it was called active-active, it really was not active-active like as load balancing. It was more like load sharing. So you would have all the load for context 1 on the first box and context 2 on the second box. Everybody okay with this, guys? This is what we did the last time around. Yeah? Kunal, can you hear me? All right, brilliant. Glad it's resolved. So now with 9.x, what they did was they actually allowed you the ability to have multiple boxes, not just two. You could have multiple, more than two, be acting as a single virtual firewall. So although I have two boxes over here, ASA 1 and ASA 2, for the remote devices, it would act as if it's a single device. So I would have one cable, let me draw it differently, different colors. I would have one cable going to the switch. I would have my second cable going to the switch. Okay, and my internal devices would be hanging off of the switch. Similarly, on the outside, I would have one cable going to the outside switch and another cable going to the outside switch. And I would probably have my external router over here connecting to the internet. From the perspective of this router or the perspective of these clients, they would not see two firewalls, they would see a single firewall. So it was actually using a single firewall, but it would load share or load balance the traffic to ASA 1 and ASA 2. This was called clustering. Understood? There are two physical hardware boxes that provide now redundancy as well as load balancing capabilities at the same time. From the perspective of the remote devices, they don't see them as two, they see them as one. So you actually get load balancing as well as redundancy at the same time. If one of the boxes goes down, at least you have one box taking care of it. We'll talk about that in terms of the physical connectivity because there are two different models. I'll talk about that. In some, yes, in the other ones, no. Everybody okay with clustering? Yeah, absolutely, no downtime. That was still there with the failover, but the problem was only one of them would be forwarding, not the other one. All right, you bought two boxes in failover, you would only be able to use one. Here I'm using both. Get the difference? Yeah, good. So now that we've talked about it, let's take a look at two different clustering models that I have. I'll write that down for you guys. Clustering allows you the ability to use multiple physical boxes as a single logical device. From the perspective, actually, both the boxes will be in forwarding state. If one of them goes down, the other is still up. Depends on the platform and the model, but it's not restricted to 2. Failover was restricted to 2. This can go up to 8. But it depends on the model, the platform that you're running it on. Take a look at the data sheet for which ones allow how many ASAs in a cluster. Also depends on the license that you have. You need to pay for it. Good, everybody? Now, the other thing that you also need to be aware of, do you guys remember with the failover? You have that failover LAN interface for the heartbeat. And config replication. Yeah. You also have the failover link, which could be potentially the same interface for what? Stateful replication. Do you guys remember that? This is from yesterday. Model depends on the speed that you want, Parkos. So it's not, the capability will be the same on all of them. The difference will be in the processing power, the number of connections per second that they process. You get my point. So 5585X would give you the same capability like a 5515X would, but the difference would be the processing power. The ability, the features are the same. Everybody okay with this, guys? I didn't get that. I meant clustering versus active passive, active active. Yeah, so depends on how many links can you have going out at the same time? Is that what you're asking? Well, let me show you the physical connectivity, then we can answer that question. So you guys are okay with this, right? Similarly, in the clustering, what you have, because you have the ability to have more than two, so I'm not going to just connect them up to each other. What I would have is maybe a switch over here in which all my ASAs, maybe I have 4 ASAs. All 4 of them would connect into this for what? For simulating the failover LAN and link interfaces. That interface is called the cluster control link. Essentially does the same thing as both of them put together. You don't need to have a dedicated switch for it. You can have a normal switch and probably use VLANs to segregate the traffic between the cluster control link and your normal data traffic. These links that I'm showing you guys over here are not for end user traffic. This is just the failover LAN interface that is just for the communication of the ASAs amongst each other. Does that make sense? So I haven't talked about going to the end devices yet. So just like you have the failover LAN interface and the failover link interface, you have the cluster control link, which is like your failover link. This is the one that all these devices talk to each other. Among these, one of the devices will be elected as the master. All right? The master is where you connect up and do all your configs. All the configs, like in failover, are done on the active device in terms of failover. Here, all the configs are done on the master. So although all 4 of them are forwarding, the configuration is only done on the master. Makes sense? So master is like the active, but not exactly like the active, because active in failover was not only the one that you would do the config on, but also the data traffic would go only on the active. Here, the config is only done on the master, but the active forwarding devices, all 4 of them are forwarding. That is absolutely correct. That's why I brought up the failover LAN interface to show you the comparison between your failover as well as the cluster controller. All good so far? So at this time, I would have the 2 devices talk to each other, or multiple devices talk to each other as if they're in a, not as if, they are in a cluster, using the cluster controller. Don't worry about the configs. I'll show you the configs in a bit. All right, now, the thing that I've been alluding to in terms of the connectivity. What are the different modes of clustering that you have? You have 2 clustering modes. One that is more common, the other one not so common. The common mode is called the span mode. This is the one that Cisco would recommend that you do. Okay, how does it work? So this is your cluster. Let's keep it simple for right now. Let's say I have 2 ASAs. ASA 1, ASA 2. This is your CCL, the cluster control link. In span mode, what you do is you connect the 2 ASAs to a switch. And on the switch, what you do is you combine these 2 ports into a port channel. This will be the same interface. So let's say this is gig 0/1 over here. The same interface, gig 0/1 of the second ASA will go into the same switch into a port channel, like a VPC from the perspective of the nexus. So the ASAs, ASA1 and ASA2 would be the VPC in this case. From the perspective of this switch over here, it is just a normal port channel. This switch does not really care whether it's one device or two devices. From the perspective of the switch, it's just a single port channel that connects up to an upstream device. Your clients are connected over here. The gig 00 interface of both the devices, they don't get separate IPs. They get a single IP. So let's say my internal IP is 10.10.10.10/24. So it's not assigned to gig 01 of ASA1 or ASA2. That is the cluster IP. So from the perspective of the end users over here, the PCs, their default gateway is going to be what? 10.11.11.10. That is the virtual IP assigned for the entire cluster. So all the interfaces, ASA1 to ASA2, ASA3, ASA4, will all share the same IP address, the virtual IP address. So when the packet comes in into your switch, the switch will be the one that will be doing the load balancing. So it sees as a port channel, it'll send one flow over here, another flow over here. You get my point? Because of the port channel characteristic, I'm going to do load balancing over here. And the same thing needs to be done on what side? The other side. So for example, over here, I would put another switch, connect these two ports, port channel this from the switch's perspective, and that's where your edge device would be. So who's doing the port channeling over here? Sorry, who's doing the load balancing over here? It is not even the ASA that's doing it. ASA is getting the traffic from where? From the switch. Ether channel. It is a normal ether channel. Whether you want to do it source destination IP, source destination MAC, whatever your switch configuration is for load balancing. The load balancing takes place based on the ether channel capability. So when the PC sends a packet to the switch, switch sees it has learned that MAC address, the virtual MAC address of ASA1, ASA2 from the port channel. So it's going to send one flow through one of the member ports, the other flow through the second member port. So the clustering load balancing is not done by the ASA. It's actually done by the switches that are connected towards it. And that's a better way of doing it because you're leaving the load balancing to a tested way of doing load balancing, which is using a normal port channel. Understood? Now, somebody had a question about how many uplinks do I have towards the internet? So towards the internet, this is your edge router. The ASAs will not be connected towards the internet directly. They would have to go through an edge router in this case. Because it's a ether channel over here. So the edge router is the one that will be actually connecting to what? To the outside. In this particular model, the span mode. So you have multiple ISPs, you would do that with the load balancing technique with the edge router, maybe using BGP multipath. But it's not the ASA that's connecting to the edges in this particular manner. And the number of links, you can have as many as you want. Not as many, there's a limit in the maximum paths in BGP, but that's how you would do it. Because the load balancing in this particular mode, which is very common, is done by the switches. So it has to connect, both the devices have to connect to a switch and do load balancing. That depends on how you want to do it, Aiseen. It's because when you do load balancing on a switch, the default is source MAC. So it does the load balancing based on a source MAC basis. But you have the other capabilities like source destination IP, source destination MAC. So it depends on how or where the traffic is flowing from. To get a better utilization over here, I would definitely do it based on source destination IP. Good so far, guys. This is what mode? This is just one of the modes. This is a more common mechanism because this is a better way of doing it. There's no, these PCs over here have no idea that they're going to what? To a specific ASA. They're just going out. When I do load balancing, Parkos, it's between two ASAs, right? This is load balancing. Generally, you're going to do it on the same site, not on two different sites. It has to be the same physical location, right? When you do load balancing, active, or any of the clustering capabilities. It won't be on two different sites. Now, there is another way of doing it. In that particular model, which is called the individual interface mode. What happens in that case, you have multiple ASAs. Let's say you have, let's say 3, as an example. What you do is you connect them up, and this has to be connected to a router. You need to connect up the 3 devices to a router. The way it does load balancing over here, you need to have, in this particular model, you need to have a router on both sides. So what you're going to do is each device gets its own individual IP address. So this IP address will be .11. This will be .12. Let's say this is .13. Let's say my network on the outside is 20.0. And let's say this is .1. On the inside, this network is 10.11.11.0. Each device gets an individual IP address, its own identity. Now, what happens in this type of setup is you run a routing protocol between the 3 devices. Okay? You also run the same routing protocol where? On the inside. So in this case, all 3 of the ASAs will advertise 10.11.11.0 to this router on the outside. Let's say router 1. So 10.11.11.0 on R1 will be learned via 192.1.20.11 because it's going to be the same cost. It is going to do it based on which is what is known as equal cost multipathing. So based on the routing, it says, oh, 10.11.11 can be reached via what? 20.11, which is this guy, 20.12, which is this guy, 20.13, which is this guy. So what it does is it allows you the ability to use a routing protocol's load balancing technique to send one flow from where? One flow will go this way, another flow this way, another flow that way. But you need to have a router running on both sides. You could not have PCs directly connected on the segment. So the PCs would have to be where? Behind the router. Their default gateway will be the router. the router would have 3 paths to the exit. So let's say he's injecting the default gateway over here because he's going to the internet. The default gateway would come into this router, let's say router 2, via what? 10.11.11.10, or sorry, 11, 10, 11, 11, 12, and 10, 11, 11, 13. You get my point? So when the packet would come from the PCs to R2, he would also use ECMP to either use ASA1, ASA2, ASA3 to go out. So the load balancing over here would be done based on the routing protocol. So you would need to have a router on both sides. Not a recommended scenario because it limits you that you need to have routers right behind the ASAs. You have to have a layer of routers on either side. So your end devices could not be connected on either side because the actual load balancing is done based on your routing protocol. But let's say your switch does not support port channeling, then you don't have a choice. You have to do it based on the routers. Even though you have 3 forwarding routers, even in this case, one of them would be your master. So all your configs you would still only do on one. Let's say this is your master. You still do the config on one. The config gets replicated to ASA2, ASA3 through the CCL. Understood? This is called the individual interface mode. So those are 2 completely different ways of connecting in. And that's why I wanted to have you guys see 2 completely different ways of connecting the cluster. You guys understand why I wanted you guys to see the physical setup before I could tell you whether it was doing 2 connections to the ISP, 1 connection to the ISP, how do you want to do it? Generally, that would be handled by the router, not by the ASAs. Understood, guys? Is the voice cracking? Still, or? I haven't said anything yet, so. You guys good now? All right, good. So let's write this down for you guys. Clustering. Yeah, let me know. Clustering has 2 modes. What are the 2 modes? Spanned mode and individual interface mode. In the span mode, I'll put recommended. The ASAs are connected to a switch. The switch sets up a port channel. The switch performs load balancing based on the port channel load balancing technique. In this mode, the end devices can be connected on the same segment as the ASAs. All right, what was the other mode? In the individual interface mode, the ASAs connect to a segment that has a router. It runs a routing protocol with the router on both sides. Oh man, 1 second, guys. Trying to write and it's hard because shoulder is. And I'll answer that question. Let me finish this. It runs a routing protocol with the router on both sides. The routers on each side will learn the same routes from all the ASAs with the same cost. The routing protocol will use ECMP to perform load balancing. Okay? You cannot have end devices connected directly on the segment that has the ASA. It has to be behind the router. Good so far in terms of clustering, guys? Now the question that Gilani asked is a very relevant question. So let's take a look at that. Let's say I had two ASAs over here. Don't forget I have the cluster control link in the middle. And let's say I'm using spam mode, which is your port channel. And I'm going out. On the inside, I have another switch, which is connecting to the devices. So let's say this client 1 initiates a connection because there's a port channel configured between what? These two ports over here and these two ports over here. The outgoing connection that is made by this client will go into the switch. Switch will send an ARP for the default gateway, which will be responded back with the same MAC address because both the ASAs use the same IP and same MAC address. So 10.11.11.10/24 is my IP, which is shared between ASA1 and ASA2. And let's say MAC1, which is a shared MAC address between ASA1 and ASA2. So when the packet comes in, it sends an ARP. It's whether ASA1 responds back or ASA2 responds back, it's the same MAC address. So when the client wants to go to the internet over here, let's say client 1 wants to go to somewhere on the internet, let's say the green device. We'll put a green device over here out here. The packet comes into the switch. Switch, let's say, hypothetically, sends a packet through here. ASA will forward it over here, goes to the router, router sends it over here. Good so far? Let's take the other device now, client 2. Client 2, let's say, is a red connection. He goes into the ASA. The first flow went here, so the second flow would go this way towards this guy, and let's say it goes to a red server down here somewhere. Everybody okay with this so far? Now on the return, when the packet comes back in, the packet hits router 1, and router 1 will do its own load balancing to send the packet either to ASA 1 or ASA 2. Let's say hypothetically what can potentially happen is the return traffic for green, although it went through what? ASA 1, it returns where? To ASA 2. How can it return to ASA 2? When router 1 wants to reach the MAC address of ASA 1, ASA 2 is going to do load balancing based on source MAC or destination MAC. So it can use either one of the two devices to send it out. Let's say it happens to send it to ASA 2. ASA 2 was not the one that originally sent the traffic out. So what they do is when the packet goes out, one of the devices becomes the owner of that flow. All right. So when the return comes in, but the owner, although ASA1 is the owner, he will tell ASA2 through the cluster control link, hey, listen, I'm the owner for this particular flow, sends the flow to the other side, but tells him he's the owner. So when the return traffic comes in, it hits ASA2. ASA2 will use the CCL to forward the traffic back to the owner, and the owner will send it back. So I will not answer on behalf of somebody else when I receive it. I will use a CCL to send it back to the original owner so that I don't need to worry about any of the asymmetrical routing issues that you have. Similarly, this guy is the owner for what? So every flow you'll have a owner over there. And this happens automatically, so you don't need to worry about it, but I just want you guys to know this is what happens. It doesn't necessarily come back because the actual load balancing is not handled by you guys, by the ASA. It's handled by the remote device, which over here is the switch. That is correct, Jonathan. Absolutely right. That is a big difference between the failover and clustering, because on failover, no data traffic goes over the failover LAN interface or the link. Here, you can have data traffic go over the CCL as well, potentially. And it does. So because you're never going to get the same, you're not always going to get the same link used that went out. For that particular flow, no. Unless that device goes down. If the device goes down, the other device sees the owner of the device is down, and one of the other devices will take over. It has no, it doesn't rebuild the flow. It has a connection entry already. It just takes over the what do you call it? The ownership of that flow. The flow, the connection table is already replicated. Well, every flow, it doesn't have to be a TCP handshake. It could be a UDP flow as well, right? Good so far, guys? Everybody okay with this? That is correct. And it's done automatically. You don't need to worry about it, because as part of the clustering, anytime a connection goes, you know how you had to do the failover link in active standby to replicate the connection table on active standby or active. Here, you don't need to worry about that. It is done automatically. Any of the 55, anything that runs 9.x. It's more than the hardware model. It's more about the iOS. So anything that runs, the model can be used. Everybody good with this, guys? So let's go ahead and now implement this in our topology over here. All right. What we're going to do for this, I'm going to set it up over here. Well, that's not my issue, Parkos. That would be the issue from the perspective of the switch. If you want redundancy at that level, what you do have the ability to do is use redundancy characteristics of those devices. For example, on the switch side, you could use VPCs if you want, right? On the router side, you would need to have multiple physical devices with multiple connections to the internet, and that would solve that issue. You understand what I'm saying? So from that also can be avoided. You can also have a single point of failure avoided at the switch level by using those techniques, which are techniques for your switches and your routers. You get my point? So if you really wanted to go that level, you do have the ability to do that. But from my perspective, I'm providing the ASA reliability. But technically, you could do it at the switch level as well.